All right, here's some practice problems for 3.5. We're going to go over the checkpoint problems first. So if you want to look at those first, and then the ones you need help with, you can certainly look through here. I'll just walk through these with you. So the first one is checkpoint 3.25. And we have our function here. We've got sine x times cosine x. What's the derivative? Well, you see this is a product. So we're going to use the product rule where sine x is my u and cosine x is my v. So then we just fill in our little grid here. U is sine x, v is cosine x. Then the derivative of sine x, which is, we're going to label that as du now. We're going to change our notation here, getting ready for differentials. So we're going to lean into the Leibniz notation a little bit. So the derivative of sine is cosine. The derivative of v is negative sine x. Then we just plug these four pieces into our product rule formula, which is u dv plus v du. I noted that here for you. As we go along, I won't put that anymore, but you can label the parts. And I will always leave them separate so you can see them if you want to refer back to the formula to make sure you know where the pieces are. So here's the u right here. Here's the dv plus v right there, and the du is cosine x. I went ahead and simplified this. You, of course, don't need to, but if you want to, if you're checking in the back of the book, or just multiply these together. So this is negative sine squared x plus cosine squared x, and sometimes those might be flipped around just to lead with a positive instead of a negative. And our next one, 3.26. This is the same thing, only instead of product rule, we're going to do quotient rule. So we have our u in the numerator, v in the denominator. Filling in our grid, of course, the derivative of x is just 1. Derivative of cosine is negative sine, and we plug that into our formula here, which I did the product rule. That's not right. That's not right at all. So no, this is wrong here. So I don't know why I was thinking the product rule. So these are the same pieces though, but the quotient rule is v du minus u dv all over v squared. So we're going to plug into that there. So the v is cosine, sorry, this is in pencil, cosine x, that's the v part. The du part is 1, so that's not making a difference, minus u, which is x. I'm just keeping those in parentheses so you can see them separate. And the dv is negative sine of x all over v squared, which is cosine squared x. That's instead of cosine x parentheses squared, I just wrote it like that. All right. And 3.27, so we have a particle moving with this formula here, square root of 3t, sorry, plus 2 cosine t, and we're moving from 0 to 2 pi, so just around the circle once. And the question is, when is this little particle at rest? When is the object at rest? So when you see rest, what that means is this. We want to find when is v, velocity, of t 0. When is the object not moving? So in order to find this, I have to find the v of t first. And remembering that velocity is the derivative of the position function. So I'm just going to take the derivative of this, which is right here, square root of 3, minus, 2 times negative sine t, because the derivative of the cosine is the negative sine. So I just simplified that here. Then we're going to take this is our v of t, and set it equal to 0 and solve. So I set this equal to 0 and I solve, and we get one of those trig functions. So this is a unit circle question. When is the sine of t negative square root of 3 over 2? Now, you may certainly put that in your calculator if you forgot or you don't have the unit circle memorized. If you put it in your calculator, you're going to get this answer. So it'll say negative 60 degrees, and that's a quadrant 4 answer. Well, I know you know that 60 degrees is 300, so there's your one answer. But remember, when we get these trig functions, you must check for other answers. So that's the quadrant 4 version when the sign is negative. But where else, what other quadrants have a negative sign value? Quadrant 4 and quadrant 3, right? So we need the quadrant 3 version of this. And so what is the equivalent in quadrant 3? It's 240 degrees. And you can check that by simply putting this in your calculator to verify that that's correct. So we would say sine of 240, and guess what your answer is? Negative square root of 3 over 2. So if you put these in your calculator, you will get that answer. Sine of 300, negative square root of 3 over 2. Sine of 240, negative square root of 3 over 2. Just remember, your calculator can't report back out those two answers because it's not a function. The question you're asking is not a function question. Okay. 3.28. This is asking you to find the derivative of the cotangent of x. Now, you probably already watched the video and you know the rule for this, but let's pretend we don't, which is the point of this exercise, which is just to find it using the quotient rule. So cotangent is cosine over sine, and so then I can use this with the quotient rule to find this. So where u is cosine, v is sine. So the derivative of the cosine is the negative sine, and the derivative of the sine is the cosine. So we plug that data into our quotient rule. Look, I got it right this time. So I get v du minus u dv all over v squared. Well, I can simplify that, and it comes down here, negative sine squared x minus cosine squared x. And then I can use this rule if I have two negatives here. Remember, no, it doesn't. I shouldn't say that. If you can always factor out a negative sign to flip all the signs. So I can factor that out to make this negative x plus y, which would make this negative sine squared x plus cosine squared, which is 1, right? So that numerator turns into negative 1 over sine squared, which is the negative cosecant squared, which is the rule, right? That's the rule we already know. So this is kind of, how did we get that rule? This is the way we did it. But if you didn't have that memorized, you could certainly do it manually and get the same answer. 3.29, fairly straightforward. 2 tan x minus 3 cotan x. What's the derivative? Just use the chart. So the derivative of the tangent is the secant squared. The 2 just stays there, obviously. The derivative of the cotangent, we just discovered that was negative cosecant squared. So this is minus 3 times that. Distribute that negative out, and I get positive 3 cosecant squared x. Pretty straightforward. 3.3. So we have our function here is the tangent of x, and we want to know what is the slope. That's just the slope of the line tangent to that curve at pi over 6. So we're going to take the derivative and then plug this x value in to find the specific slope. The derivative is, of course, the secant squared. So we're going to find what is the derivative at pi over 6. So what's the secant squared of pi over 6? Well, if you didn't know, and you don't have it the unit circle memorized, you would know that the secant is 1 over the cosine. The cosine of pi over 6 is square root of 3 over 2. Your calculator will certainly tell you that. Unit circle will tell you too, but we're just pretending you don't know that, and so your calculator would tell you this. Because remember, your calculator can't tell you the secant. You have to do it manually. Well, if this is the cosine of pi over 6, then the secant of pi over 6 is the inverse, right? The reciprocal. So not the inverse, it is the reciprocal. So it's 2 over square root of 3. Then I'm plugging that back into here. So I get 2 over the square root of 3 squared. Square the numerator, square the denominator, and there's my answer. Let's see what else we got here. 3.31. Oh, this is our cycling of our derivatives with the sine and cosine. So this was super simple. It just said if y is the cosine of x, what's the fourth derivative? Well, you know the fourth derivative is the one that repeats. So the fourth derivative of cosine x is cosine x. The 8th derivative of cosine x is cosine x. The 12th derivative, right? Every multiple of 4 is itself with the cosine and the sine. Not with the others, just these two. And then number 32, this is, like I said, a very common SAT, GRE type question. So what's the 59th derivative of the sine of x? Well, first of all, we want to say, well, what's the closest, or in this case, we're going to, the the one right before, what's the multiple right before that? So 4 times 14 is 56. So I'm going to back up, not 59, but I'm going to back up to 56. So the 56th derivative is sine of x. Then I can go forward. So if that's the 56th derivative, then the 57th would be cosine. 58th would be negative sine. 59th would be negative cosine. Now, if you're really slick, you'd say, well, wait a second. I can just go to the 60th derivative, which is sine, right, and go backwards one. Hey, you certainly can if you can think backwards like that. There's no you don't have to go forward, you don't have to go backwards. It's just, and I'm showing you that pattern in here. Either way works, my friends. And let's see, 3.33. So here we have a particle. Its position is given by 2 sine t. Okay. They want us to calculate what is the velocity at 5 pi over 6 and what's the acceleration at 5 pi over 6. And then they want us to say what is happening there. Like what's the object doing relative to its velocity and its acceleration. Okay, fine. So we need to find the velocity function and the acceleration function. You know that the velocity is the derivative of the position, so that's going to be 2 cosine t. And then the acceleration function is the derivative of that function, so the derivative of 2 cosine t is negative 2 sine t. So then we're going to plug in our value here, and remember that 5 pi over 6, for those of you that are radian phobic, that is 150 degrees. So the velocity at 5 pi over 6 would be 2 times, and again, this comes from the unit circle or your calculator, 2 times negative square root of 3 over 2, which would be negative square root of 3. So just right there, what's the object doing? Well, it has a negative velocity. So depending on how the object is oriented, if it's going up or down, I think this was a spring, I think was this example. So in this case, it's oriented vertically. And so then this would mean that it is falling at this time here. The acceleration at 5 pi over 6 would be negative 2 times the sine of t, the sine of 5 pi over 6, which is a half, which gives us an acceleration of negative 1. So what's happening? Well, if I have negative velocity and negative acceleration, that means that my object is falling and it's speeding up while it's falling because I have negative velocity and negative acceleration. They're working together, so the object is speeding up. Remember, if this happened to be positive, that would mean, yes, the object is moving in a negative direction, but it is slowing down because acceleration and velocity are working against each other. Okay? All right.